Hello, this is 8-5 Angles of Elevation and Depression, and part of what you're going to be doing is identifying which type of angle something is, and the other part is going to be using that information to find distances or angles in conjunction with trigonometry. So the first thing we need to talk about is what they are. Everything has to do with the horizontal line. So we have a horizontal line going out from the eyesight of the person standing on the ground, and we have a horizontal line going out from the eyesight of the person up in the hot air balloon. From the horizontal down would be considered an angle of depression. Depression is when something is lower than it should be. So, but it is definitely from the horizontal down, angle of depression. Now, if we're talking about from the line of sight of the person on the ground looking up at the person in the hot air balloon, from the horizontal up would be considered an angle of elevation. So, from horizontal down is angle of depression. And from the horizontal up is angle of elevation. So if we look at another picture, we've got a hiker, and we've got the top of a mountain. We've got the horizontal line from the top of the mountain. We've got the horizontal line from the hiker's eyesight, and we've got a horizontal line on the ground, down in the valley. So from the eyesight of the hiker up to the top of the mountain, here that would be considered an angle of elevation. And we do include the perspective from the hiker to mountaintop. Okay, but from the hiker down to the house in the valley or the cabin, from his horizontal down would be considered an angle of depression. From the hiker to the cabin. But if you're down in the cabin, we also have an angle of elevation up to the hiker. So it'd be angle of elevation from cabin to hiker. And if we go all the way to the top, and again that should be a horizontal line, from the mountaintop to the hiker, we have an angle of depression. So that is from mountaintop to hiker. So part of the process is learning how to just identify which angle we're talking about. You want to be careful on these because the angle, if we were to draw a vertical line in, the angle between the line of sight to the vertical is neither elevation or depression. We only get angles of elevation or depression when we are coming from the horizontal up or from the horizontal down. So one of the ways that we can apply this in real life is to word problems. And the first word problem we're going to look at says that we see a rock climber on a cliff at a 32-degree angle of elevation. So if we are here and the rock climber is on a cliff up here, our goal is to draw a right triangle. We have the vertical, we have the horizontal, and quite often a direct distance Now in this case, it'd be the direct distance between the person spotting the hiker and the hiker, or rock climber. Now it says it's a 32-degree angle of elevation. Going back to what an angle of elevation means, that would be from the horizontal up. So that could only be talking about that angle. So we would mark that as 32 degrees. If we go on to read the problem further, it says the horizontal ground distance to the cliff is 1,000 feet. So this is our horizontal distance of 1,000 feet. And the question is, find the line of sight distance to the rock climber. So this direct or line of sight, and that is the distance we're looking for, which is x. So in this case, if we redraw this triangle without all the labels, we have 32 degrees, 1,000 feet, and x that we are looking for. So using trigonometry, according to this angle, this side would be adjacent, and that length would be the hypotenuse, and adjacent and hypotenuse require that we use cosine. So we would set up our problem as the cosine of the angle equals the adjacent of 1,000 over the hypotenuse of x. We've talked about this in previous lessons. With all the algebra used to solve this, the cosine of 32 and x end up trading places. So we will have to divide 1,000 by the cosine of 32, which ends up being approximately 1,179 feet. Okay, so we will talk about another problem. An airplane pilot sights a life raft at a 26-degree angle of depression. So we have our airplane and the horizontal of the airplane sights a life raft. So here's the life raft at a 26-degree angle of depression. Since depression is from horizontal down, this would be our angle of depression. It says the airplane's altitude is 3 kilometers. So that means from the horizontal that the life raft is on, we have a distance of 3 kilometers. It says, what is the airplane's surface distance, d, from the raft? Well, there are two ways that you can do this. Since 26 degrees is actually the angle of depression, that angle is not inside the triangle that you might have just created. Now, if these are both horizontal, they are parallel, so we do have alternate interior angles, making this angle also 26 degrees. But if it is easier, instead of having our vertical here, we can do our vertical here, because it would still be 3 kilometers, and we could use that triangle. But 26 would have to be inside the triangle that we are creating. So whether you call this 26 or that 26, it needs to be inside. It says we are finding the airplane's surface distance from the raft. Since this would be a rectangle, we're either talking about this distance or it could be the same as that. So we will call that d. So using trigonometry, if this is our angle, this would be opposite and this would be adjacent. So we would use tangent. The tangent of 26 degrees equals 3 over d. And again, we would swap those. So d equals 3 divided by the tangent of 26, which ends up being approximately 6.2 kilometers in length. Now, there are some instances where our angle of elevation or depression is not right from the ground. I'm going to set up number 17 in the homework. And the rest you will have to sketch out. So 2 office buildings are 51 meters apart. So this is the picture that we have. And their distance in between is 51 meters. It says the height of the taller building is 207 meters. That is the entire height. The angle of depression from the top of the taller building to the top of the shorter building is 15 degrees. So here's our horizontal. Since it is an angle of depression, that would be here. It says that is 15 degrees. Find the height of the shorter building. So we need to find the difference between the two in order to subtract it from 207. So this is what we're looking for. This is where you need to be careful because 15 is not inside our triangle. So using alternate interior angles, if this is 15, then that is 15 as well. The other thing you could do is this is a 90-degree angle, so we could find the measure of that angle by subtracting 15 from 90. But this would be a nice tangent problem because you have opposite and adjacent. So we would say the tangent of 15 equals x over 51. We would multiply both sides by 51. So if we do that calculation, we get 13.7 approximately. That is this distance right here. So we would have to subtract that from 207. Which is 193.3. So that would make this distance 193.3. Again, those are approximate. So to recap what we did, we first figured out what an angle of elevation and depression is and described different angles in a picture based on that information. And we also used that information to set up right triangles in order to find distances that we're looking for in real life situations.